Uh, can you all check? You see the quiz on Canvas? Okay, cool. Let's get started then. Okay, so we're gonna move to power series. So power series. So these are, you could think of it like n equals 0 to infinity. Cn x to the n. If you want to write it out, it's just like this. Right. So a polynomial can be a power series, right? I mean, a priori, this is the infinite degree polynomial in a way, but if like maybe after some point all ci's are 0, then it's a polynomial, right? Like x squared is basically c2 is 1, and then the rest of the cn's are 0, right? So okay, so one question is to ask, where is f defined? In other words, if I plug in something, if I plug it in, do I get a number? Right? Like here, not defined at 0, right? Agree? So 1 over x is not defined at 0 because, I don't get a number if I plug it in. It doesn't send 0 to like a specific number. So you could see that what it means to converge is this, right? F of a is defined at a, meaning that this thing is a number, which in particular just means this thing converges, right? So basically wherever this thing converges means, means f is defined there, right? So convergence means f defined at a. So let's do an example, right? Like f of x is n equals 0 to infinity x to the n. So f of 1 is n equals 0 to infinity 1 to the n, which is an infinite sum of ones. This diverges, right? So f is not defined at 1 because, you're not equal to some number at 1, right? So f of a half, you can check it is. At this point, this is a geometric series. I'll let you, figure out what the number is. But the point is this converges because your r is as r is 1/2, which is less than 1. So like basically the idea is for every point you plug in, that's when you use all your tests, right? All the tests you've learned is after you plug in like whatever point you do. But no like sane person is gonna check point by point, right? Like you're not, if I ask you to check where is f defined from 0 to 1, you're not gonna check every number from 0 to 1, right? There's infinitely many. You're not gonna do that. And when you do like check a third, a fourth, a fifth, a sixth, like turn by, like that's impossible, right? So let me just say you don't want to. It will certainly work, right? You could check turn by turn, but then like point by point, you don't want to test points one by one, right? That is just inefficient. So instead, you use the test that gives you almost everything. And guess what that is? It's ratio. Right? Ratio gives you almost everything aside from the fact that if the limit's 1, right? So, for example, this one makes sense. N equals 1 to x to the n over n. So let's use ratio test and see what happens, right? So again, it's x to the n plus 1 over n plus 1, and then I divide by an, which is multiplying by the reciprocal. And this is just becomes x. So I have absolute value of x times n over n plus 1. There should be an absolute value on the n over n plus 1, but n's going to infinity, so it's positive. So n over n plus 1 just goes to 1, right? When you go off to infinity. So this is your limit. Yeah, this is like your L in your ratio test. And what do we know from ratio tests? When L is smaller than 1, it converges, right? When it's equal to 1, inconclusive. And when it's greater than 1, diverge, right? Obviously, we don't care about the diverge case. We care about where it converges. So this thing, we immediately know it converges here. Yeah. So here is the tricky part, right? At this point, x equals 1, we need to check, right? Because the test is ratio test just doesn't work at these 2 points, right? When absolute value of x equals to 1 means x is plus minus 1, right? And if you like, these are like the boundary points. So we have to check it case by case. So when x is 1, right, I just get 1 over n, in which case this diverges as, you know, it's the harmonic series, right? Harmonic series. When x is -1, right, this thing converges by alternating series test, right? Not gonna go fast as we sort of done these already. So you see your interval of convergence, if you like, it's this. Yeah. Or if you like, you could prefer to write that. Yeah, so this is called the interval of convergence. And the radius, I think, is obvious. You just find the midpoint and then you check the distance from the midpoint to one of the boundaries. But radius of convergence is 1 in this case. So let me just say, right, like it could be it's the interval of convergence, right? So it could be the interval is the whole real number, so negative infinity to infinity, in which case your radius is infinite. Or you can have an interval. This one's sounds a bit weird, but it could just converge at 0. Let me make myself clear. It's wherever your series is just sum of zeros. In this case, it is 0, because if you plugged in x equals 0, you clearly just get infinite sum of zeros, right? 0 to the n divided by n is 0. So it clearly converges at 0. So you always converge at the center point. It could be in other questions it's not centered at 0, in which case it's whatever that point is centered at. But your interval could be a point. Yeah, it sounds a bit weird, but I mean, since you always converge at 0, it's possible the only point where you converge at is 0. And in that case, right, like you would say the interval of convergence is 0, and then the radius of convergence is 0. Yeah. Okay, but moving on, let's do one more. So something like n equals 1 to infinity, n over 5 to the n times x to the n. Again, ratio test. N plus 1, x to the n plus 1, 5 to the n plus 1, 5 to the n times x to the n. Again, these cancel the x, these cancel the 5. So you have limit n goes to infinity, absolute value of x over, absolute value of 5 is 5. So, and again, since we're going to infinity, we could just remove that. So when n goes to infinity, n plus 1 over n goes to 1. So this goes to this. So this thing is like your L in your ratio test. And again, it's 3 cases, right? when this thing is less than 1, it converges. How about right like this? Right here. So this when it's less than 1, it converges. When it's equal to 1, inconclusive. And when it's bigger than 1, it diverges. This looks so ugly. Diverges. Okay. So you could translate this, right? This means absolute value of x is less than 5. Absolute value of x is equal to 5. And I mean, we don't really care about diverge. The question is determine the interval and radius of convergence. So from here, right, we know it converges from here. Now, again, when is absolute value of x equals to 5? That's when x is this, right? So again, you have to check your boundary points. So in short, find the interval, check boundary points if you want to summarize everything. But the reason you check boundary points is because of the inconclusive part. So let's check x equals 5. So sum n equals 1 to infinity, n over 5 to, so when x is 5, I just get this, right? In which case it's just n, and this thing diverges, right? By test for divergence. Because limit n goes to infinity of n is not 0, right? Everyone agree? So, and then you check x equals -5. Now, -5 to the n can be broken up to -1 to the n times 5 to the n. So these will cancel. So really, you just have a sum of n times -1 to the n. And this thing again diverges by test for divergence. I'm skipping the convert. I'm skipping like the testing part because we spent like a whole 2 weeks on this, right? So yeah, the limit is not 0, right? The limit of this does not exist. You're oscillating between bigger and bigger numbers in absolute value. So in this case, your radius is just this. Your radius of convergence, I mean your interval of convergence is just open parentheses, and then your radius is 5. Yeah. Everyone clear on this? So in short, ratio tests, and then you get like an interval, open interval, and then you check the boundary points because of the inconclusive part, and then you should be good. Okay. Let's move on then, if you have no questions. So the next thing is, can we represent functions we know as power series? And here's the most basic one, is the one I went over. You could re-index this if you don't like to the formula you know. This is, if you re-index, it's just this. I mean, re-index to start at 1, and then this is your A, this is your R, right? Remember, so it's A over 1 minus R, right? So in this case, A is 1, R is 1, R is X, so it's this. So since R is X, I mean, this is true for absolute value of R less than 1, but since R is X, it's true for, I mean, it's equivalent to being this, right? So when, let me just write like this. When absolute value of X is less than 1, this function can be written like this. Yeah, that's the moral of the story. So we could take this and use this fact, right? So we could generalize it. So we have this formula, if you like, AR to the n. If you don't like, if you like the starting at 1 thing, we can also do that. But the point is, this is equal to a over 1 minus r. And for now, everything you do power series on is based off of this. Until we get the Taylor series, which I believe is next time. But the idea is, well, let's see, right? Let's do an example just to see how it works. I want to express this as a power series. Well, it's pretty much close to this, right? I have a number over something minus something, except I need the first part to be 1. So let's make it a 1. Yeah. Now, I can't have 3 times something, right? So let's move that to the top. And now we're golden. This is your A, this is your R. Yeah. So again, this is only true when absolute value of R is less than 1, right? So since R is x over 3, when absolute value of x over 3 is less than 1, or if you like, if you solve for it, when absolute value of x is less than 3, this is equal to this summation, n equals 0 to infinity. A is 2/3, and then my R is x over 3 to the n. Right, so I'm using this formula right here. Again, sorry, let me just write this. And you could simplify this. Yeah, so this function just has this power series expansion inside, when absolute value of x is less than 3. Good. Let's do one more. So example. So what about 4 over 2x plus 3? So again, let me remind you, I'm going to skip that one part, but AR to the n is A over 1 minus R. So again, you're going backwards. Before, remember, for geometric series, I give you the series and you write the function, right? So now it's, I give you the function, you write the series. So again, I need a 1. So let's move the number before the variable. And then let's factor out a 3 to get the 1, right? And I can't have 3 times something, so I do 4/3, right? And we're pretty close. We have a number over 1 plus something. Here is a number over 1 minus something. So how do I change plus to minus? What's a smart way to change plus to minus? Yeah, minus minus, right? And you're done. This is your A. This is your R. So again, inside your interval, since your R is this, it's when absolute value of R is less than 1, right? So when absolute value of x is less than what, 3/2? It's equal to this. 4/3 times what? Negative 2/3 x to the n. And then from here, I mean, you could simplify, it really doesn't matter, right? 2 squared, 3. I mean, if you want to simplify, you're going to get this, a 2 to the n, x to the n, a 3 to the n. So if you really wanted to write it as a power, as a power series form, like you to the, what is this, n plus 2 times x to the n over 3 to the n plus 1. Yeah. So, and of course, what I mean by power series form is, remember, what is the power series? It's something, it's Cn x to the n, right? So basically what I'm saying is, at least for the first one, like, hopefully you can see it. This is your Cn, if you like. And then from the one we just did, like, this is your Cn. Yeah. So that's what I mean by like power series form. Is everyone clear on this? Pretty much, yeah. I mean, like, again, the final, right? If the final doesn't, if the final, the answer choices, they leave it like this, then, then, you might as well just choose this and move on, right? So, but I'm saying, like, if the answer choices simplified it, then you should probably simplify, right, to check which one's the right answer. Okay. Let's move on. So we could actually do better. And there's a theorem that helps us get more functions. It's still based off of that formula, but the idea is inside the radius of, or radius, if you like, or interval of convergence, you can integrate / differentiate term by term. This is informal. I'm not gonna write the actual theorem. I feel like the formal differentiate, like the how do I say it? The formal way is just, it's like, it might confuse people. So really, all it's saying is this: inside your radius of convergence, you could do this. So inside radius of convergence, this thing, the idea is, can you move the derivative inside? Yeah, that's all it's saying. Inside you can move. So these are two different things, right? The first one, you are summing everything up first, and then you derive it. Yeah, this one's different. This one is, you derive each term in the sum first, and then you sum. Yeah, so here's, you derive each term and then sum. Here it's, you sum everything and then you derive. Yeah, or not derive, differentiate. Yeah. So and of course, if you know math 2a, the formula is, the index changes. I'll explain why. But the idea is, you know the formula, right? It's n times x to the n minus 1, right? Power rule. So, and the reason it's 1 is because, if you think about it, this thing has, the original thing has one less term, and they're both infinite, right? You're going off to infinity, but this one has one less than this, right? Because when you derive the constant term, when n is 0, if you plug in n equals 0, right, it's Cn, or C0 x to 0, which is C0. It's constant, right? When you derive the constant, it goes away. So you're actually starting at the first term, right? So that's sort of why it starts at 1. It makes sense, right? Because if n was 0, you would have x to the 0 minus 1, right? There's no way to get a 1 over, to derive and get a 1 over x from like a polynomial of infinite degree, right? If you have something like this, there's like, you could just check it, right? There's no way to get a 1 over x from deriving this, right? Everything is like positive power. So yeah. Okay, and same thing for integrals. So if I integrate Cn x to the n dx, this is the same as, so inside the radius of convergence, let me just, for both, this is the same as integrating this. And when you integrate, you don't lose any terms, right? So it's just the power rule for integration. I trust you all know the power rule for integration. It's this, right? So, and then of course, plus C. So again, here you are summing everything first, and then you integrate. Here is you integrate every term first, and then you sum. So by integrate every term, you know that's where the term by term comes in. Wording comes into play. Okay, let's do an example and see what I mean. Yeah. So if f of x is ln of 5 minus x, we can actually find the power series expansion for this. Because we don't know this, but we do know, again, let me just write, everything is still this formula for now. You are only using this and this only for now. Everything is based off of this. Let's take derivative. Derivative of natural log is this, right? Which in turn is chain rule. Should be this, right? Now the derivative looks a lot like this, right? The original function didn't, but the derivative did. And so let's put it in that form. It's what we did before, right? I need a 1 minus something. So let's factor out the 5. So now it's negative 1/5 over 1 minus x over 5. This is your A, this is your R, right? So again, when absolute value of x over 5 is less than 1. So if you like, when absolute value of 5 is absolute value of x is less than 5, you use the formula, right? A is negative 1/5. X is, I mean, sorry, R is this, right? So you get this is your series, if you like. Now here's my question. I have f prime is represented like this. So how can I go from f prime to f? I have the power series for f prime. So how can I go to f? What do I need to do? What operation? So again, and this is true, I'm saying I have this. So how do I go to f? What do I need to do? Yeah, exactly. That's exactly what I mean. We're using this part right here, the second part. We're integrating. So this is, we just integrate, right? F is this plus C. So, and again, we could do it term by term, right? I mean, I skipped a step, but the integral was outside, but inside the radius. I'm using the theorem, so inside the radius of convergence, we can move the integral in. And at this point, f of x is this, right? Negative x to the n plus 1 over n plus 1 times 5 to the n plus 1 plus c. So this plus c. Now let's figure out what c is, yeah? I'm going to erase this for room because I want to keep it on the same page. So c is actually pretty easy to find because f is this, right? So what's f of 0? You just plug in your center point. F of 0 is ln of 5 minus 0, which is ln of 5, right? Now, all you do, I mean, at this point, so if these were to match, well, I plug in 0. I don't care what the bottom is. This thing is just 0, right? So this thing is an infinite sum of zeros plus c, which is 0 plus c. But I know f of 0 is ln of 5. So C is just ln of 5. Yeah. Everyone clear? So again, even though it's natural log, everything is based off this. Like, it's just if you see natural log or something different, it's just some derivative difference or an integral difference. For example, if I gave you something like this, it's very simple because you know that the derivative of this is this. Agree? If you use quotient rule, I mean, it could be there could be a plus minus, but pretty much is this, right? And and we just went over the power series expansion of this. It's this, right? So this one's the opposite. We want to take derivative instead of integrate. Squared. Then again, inside your radius of convergence, in which case this absolute value of x is less than 1, right? This thing is just this, right? So again, this is equal to this when absolute value of x is less than 1. So when you take derivative, I told you, right? You get a 1 n times x to the n minus 1, right? So this is the power series expansion for this. And of course, if you wanted to actually write in, you can re-index to 0, right? But this is pretty much the power series expansion. So I don't know. I mean, like if they gave you something like this, you just at this point it's just this is x times this. So we just did this one. It's and you're done. So basically what I want to say is, well, like the same goes if you see like something cubed or like it's just two derivatives now. Yeah. Instead of, I mean, you might have to multiply by something because it might not be nice like the 1 here, but the idea is the same, right? Like you either have like a natural log, in which case you're integrating, or you have powers of like a over 1 minus r, in which case you derive. Is everyone clear on this? Yes? No? Okay, cool. You have like 2 minutes to study. And then yeah, so next time we'll just go over Taylor series and then we're good.